Hey everybody, welcome to part 4 of our EICO ST70 video series, and I want to start out by showing you cleaned up the knobs as best I could. And as you can see, I used the hydrogen peroxide hair bleach method, and you can see it came out pretty good. And in our second video, or third video, I'm sorry, we punched out some center pieces for this. I decided to go with the convex ones just because they look a little different, and as you can see, they popped right in, and I think they look pretty good. Definitely the price was right for the little piece of aluminum I had down in the shop, so it didn't cost me anything to punch them out. And as you can see, I think it did pretty good. So our knobs are ready to go, and I know you're all going to ask about how I clean these knobs. So I'll just go over it with you real quick because it's very, very simple. So you go to, now I bought this at a a beauty supply store. Okay, here in the United States, there's a place called Sally Beauty Supply. They're a chain, but I'm sure, anywhere you go, this is a very common thing. And basically, the main thing you want to be interested in, this is a cream style. It's almost the consistency of shampoo, and really, what its purpose is for bleaching hair. So if you want your hair to be bleached, light color, blonde or whatever, this is the kind of thing they use. Now these numbers apparently, and I'm learning this myself because I don't know anything about this kind of hair stuff, but this number has to do with how concentrated the hydrogen peroxide and so forth is. So the bigger the number, 40 is the highest number I could find. It starts at 10. So there's 10, 20, 30, and 40. 40 is the strongest one. So I guess this is really intense to put on your hair. It's really bad for your hair, what I'm told also. But it's used for bleaching hair. Anyways, if you buy a product like this, the main thing you want to look at is the ingredients. And if you look at the ingredients down here, it has water. But the very next thing should be hydrogen peroxide. So it has hydrogen peroxide and phosphoric acid. And those are the things, then it has alcohol, a few things like that. But really the hydrogen peroxide being way up on the list, that's the important thing you're looking for. And when you look at this stuff, it has the consistency, I don't know if you can see it as I squeeze the bottle. It has the consistency of shampoo or thick soap, liquid. And the idea behind this is you can just take a little brush like this and you pour some of this into a small container and you brush it really well on this. And it does say, even though you're supposed to put this on your head and put this in your hair, it tells you it can cause severe irritation and possible permanent eye injury. I don't know if you could see this on the camera. And it also says do not use if scalp irritation. And then it says avoid with eyes, but it also says avoid contact with skin or clothes. So I guess this can be nasty stuff. So I didn't take any chances. I put on a pair of disposable gloves when I handled it. I brushed it on the plastic really well. I placed it into just a plastic Ziploc bag, a plastic baggie, and then kneaded it around so that it was well covered, and then laid it outside in the sun, in direct sunlight. And I just kept rotating the bag around so that the sun could equally work on all of these. And then left it out for the whole day during the sun, with the sun shining on it. And by the end of the day, took it out of the sun, brought it in, took these out and rinsed them really, really well with water, dried them off, and this is how they turned out. No scrubbing, no rubbing, no any kind of work involved at all, other than just let the sun and the hydrogen peroxide solution do its work. So turned out pretty well. I'm pretty happy with it. And then all I did was I just press fitted these right in there. Just pushed them in, no glue, no nothing, and they're in there really tight. So these will be acceptable. Now, the bad news is with these knobs, there's a problem. If you notice, there are two different types of these knobs. So if you flip them around, there's the kind that have this, like this knurled compression fit, and then you have these dual split knobs that have one compression fit and then one spring clip fit for the two pots. So in other words, the treble and the bass have separate knobs for right and left channel. And the problem is I'm not real happy with those pots the way they are in there, and they may need to be replaced. And if I replace them, let me put you back down here, if I replace these, then what's going to happen is these two knobs are not going to fit on the new one, because the new pot that I put in will just be a dual ganged single pot, single shaft pot like this, which means these won't fit anymore, which means I won't be able to use these knobs. So I'm still kind of deciding about how I want to handle that, whether I just want to replace these pots and put all new knobs on, replacement knobs. They're not expensive. You can buy knobs pretty cheap. Or if I want to just try to clean these really well and reuse them. So that's my first option I'm going to try. The other thing I'm going to do is I've disconnected these two right here. And if you notice, this one here, this switch right here is the speaker phase for normal and reverse polarity. And of course, I've removed those. I'm not using that. And the other one was the balance that I showed you in the last video that I'm removing. So these switches are no longer used. So if I do replace these pots, then the other thing I will do is I will make one of these switches, I'll put a new switch in, and that'll become the new power switch that I'll move from down here. And then this one here, I'm probably going to turn into a tone bypass switch, meaning it's just going to completely bypass the entire tone stack altogether, so that I can have just a flat line level amplifier with no tone control. I kind of like having the ability to do a tone defeat, like on all the Pioneers that I was working on and so forth. You've seen in the previous videos. So I'm still debating whether I want to do that. The other thing is this is the high filter, this is the low filter, the loudness. All of these switches are in really bad shape, and again, we're going to do the wobbly camera again, but I want to show you, if you look inside here, all of these switches, let me zoom in for you, all of these switches are really bad. Like if you look right here, see how that's curved? And you can see when I move the switch up and down, you see how it's just not making good contact anymore. So the bottom line is these are going to have to be replaced. They're just too far gone. I mean, it's one thing about dirty contacts. If you clean them, it's totally another thing to talk about if the Bakelite portion of that fiberboard part of the switch is actually distorted and loose. So I was able to go and find a replacement set of switches, and if you look here, they are right here, and they're pretty much exact replacements, and they're pretty good quality. So if you look at this one, these are just the double pole, double throw, but I also have the 4-pole double throw switches like these other ones here are. You can see they're right here, and they still make these, and you can see these ones look to be fairly good quality, so I can definitely replace these if I decide I want to do that. So definitely, and the other thing is, again, my feelings about using ceramic capacitors in the tone control section. I'm not real crazy about that, so these are all going to get rebuilt. And as I told you earlier, I do have a modification I'm going to do on the loudness circuit, kind of like how I did a modification on the loudness circuit of the Pioneer SA8500. This loudness doesn't work very well on these amps. It's a known issue with it. These amps, when they were originally built, were a little bit weak in the bass section, and the loudness switch really didn't do much to it as well. So we're correcting all of that. That's pretty much all I have to say for this round right here. When we come back here, we're going to start working on those tone controls right here. And I'm not sure how I'm going to fit those in there yet, but we have to figure that out. And I'm going to get rid of these little couplets because obviously they're bad. If you noticed, we barely even moved the tone controls when we had the signal generator on it, the audio generator. And if you remember, our square wave just went completely crazy. And even on a sine wave, we were getting little oscillations and things. These are bad, and these couplets are known to go bad. So they're going away. We're going to replace them. So we're going to do a tone defeat. We're going to possibly replace the pots if we can't clean them well enough, and then or rebuild them. And then we're going to replace these couplets with our homemade tone stack, and then start working on the low pass, high pass filters and the loudness switch. So that's all going to be in this next video here that we're working on. All right, so more to come here, and just stay tuned and we'll see where this ends up. Okay, this made my decision pretty easy. We're going to have to replace these pots. I took them apart, cleaned them really well. This one cleaned up perfectly, but the thing I noticed was this back pot has a different resistance than this front. The front one's about 495 or 490K, which is, it's a 500K pot. That's good. This one's about 560K. So really between the two there's about 60 or 70K difference, which means these two pots are not exactly going to track the same. So right there, your treble's always going to be out unless you move them the right amount apart. And that's what this was doing. So, but it is very clean. This one, the rear one is bad. The whole pot is bad. This front one is okay, but this back one, we have connectivity from here to here, but there must be a little crack somewhere in the pot on this one. And that's probably why the bass control wasn't working properly. So these are going to get replaced. I do have some modern replacements to go with. There's the 500K. And I'm going to do away with the switch. And these ones are in really nice shape. They're brand new. So that's looking like what we're going to do. So we'll keep plugging along here. Alright everybody, lots of changes since the last time here that I was on. So let's give you the nickel tour, and we're just about complete with this thing and ready to do some sound checks. First thing I did was cleaned up the power supply a little bit. This amp is just extraordinarily quiet now, and I think we got the power supply right where we want it. Now, from the first video, you saw all of this that I did with these and so forth. But what else I did was I removed this 1.8K resistor, okay, and replaced it. Okay, and if you look on the schematic, this is right here. What this does is this part that comes straight out of the rectifier gets filtered with a 40 microfarad capacitor. It goes right up to the center taps of your output transformers. Okay, so if you look at this, you can see right on the output transformer. Now, I took that out and I swapped it out with a chassis mount 1.5K. So I dropped this a couple hundred ohms. It doesn't make a huge difference. But what it's going to do is it's going to, this resistor here provides the drop for mainly right here, T, which is, if you look on here, these are your screen grids for your tubes, for your output tubes. Now normally, by running this in beam power mode, which is what we're doing, you basically put a little bit lower voltage on the screen than you do on the plate or on the anode. Okay, if these are tied together, then you're making the tube run in triode mode. But by running it this way, you're increasing the gain of the tube and all that. We won't get into that in this, but suffice it to say that T, that 1.5K, is just giving you a little bit of drop. Now that's pretty normal. A lot of times you either see a 1K or 1.5K resistor on each screen grid. Well, all they did was they just dropped it with one big resistor and then split it amongst all of them, and that's fine. It works fine. So I changed that. That little bit of voltage difference isn't going to make a huge difference. I'm going to have to maybe rebias a wee little bit, but not that bad. Not that bad. Then the next thing we did was we went to this 2.2K. Because I dropped this, I raised this just a hair. I took it from a 2.2, as you can see up here, I went to a 2.4K. Okay, and yes, everybody's going to say there's a 100 ohm difference of the overall resistance. It's really not going to make that big of a difference. It's going to work. Okay. Again, way overkill for this resistor. The one that was in there was just a 2 watt. This is a 20 watt. But this is all I had, and I'm not waiting for more things to come in through the mail and paying $8 for shipping and all this other stuff. I just want to get this project done, and it fit, and it's okay. It's going to work fantastic. Actually, if anything, it's better than having a smaller one. So that's in there. The other thing I did, if you notice here, is a 0.22 microfarad, and over here is a 0.01 microfarad, and essentially, or 0.1, I think. Essentially all these is their little bypass capacitors, and they're just shunting across a couple of these caps here to basically give us, it basically filters out the high frequency component. What you find out is on electrolytic capacitors, when you get higher capacitance, because of the way they react to high frequencies and so forth, they can't always filter ripple that's in the noise range rather than just in the 60 hertz 120 hertz range. So it never hurts to bypass them with a smaller capacitor that basically is just there to clip off any kind of high, like hiss or high frequency noise. And that's all we're doing there. Okay, so I just put those in. Probably don't really need them, but for what they cost, I put them in anyways. Okay, the rest of this all looks pretty similar. If you look in the bottom before we flip this thing over and see the big changes that we made, these 4 lines that are going to the pots and going to the tone control section that tap off the various parts of the from the amp, I actually used shielded cable to reduce the noise. If you notice, there's filament lines going all over the place, and even though it's twisted wire, you still got noise all over the place it could pick up. So by going with shielded wire, we're eliminating the possibility of any of that noise. It's reducing it greatly. That's about it. I think all the rest of this stuff I showed you all in the previous video. So none of that's changed really. It's all the same. So now we're going to flip this over and we're going to look at the other side, and we're going to go over the big changes that we made in the tone control section. So stick with me here and we'll be right back. Well, it works. It sounds great. Let's go over a little bit of the things here that I did on the top, and we'll go from there. I'll be right back. Okay, we're going to take a little side view here of the amp, and what I'm focusing you in here on is the tone control section. As you know, I fitted up a couple of little circuit boards I made, but really they were noisy and I didn't like the way they fit in there, and I just didn't like the whole idea, so I kind of scrapped that. And looking at how simple the circuit was, I just reproduced it. I used the same component values as the schematic, and I just did point-to-point wiring between the pots, and as you can see, it turned out really well. It was very, very minimal components, so really pretty simple. I got rid of, as you know, the speaker phase reversal switch. I removed the balance control switch. This is the balance, or this is the balance here. This was the speaker phase. Took the speaker phase switch totally out and replaced it with a new power switch. As you know, we measured the bass and treble pots, and they were just shot. I took them apart, I cleaned them, I did everything. They worked, but the values were out. The resistor they just weren't any good. So that leads me to the one problem I have, and that is the pots that I had on hand had little short half-inch shafts. So finding knobs to fit them is going to be a little bit of a challenge, but I'm still working on something for that. So I have some temporary ones on there for now. Tone control is dead silent. As you can hear, when I turned the volume down, the amp was really, really quiet. If we move along here, gone are the low cut and high cut controls and all the capacitors and all the noisy wires. And I got rid of all that. I'm never going to use them. All they did was just put a lot more switches and wires and components in the signal path to make noise. I eliminated it. The only switch that is still active is this one over here, which is the loudness control. Now let's talk about loudness control for a minute. It is a well-established, well-known fact that the loudness did not work on these as they came from the factory. The design was not correct. So I made a couple of changes to correct that. First thing, if you look on the schematic, here's your input to your line stage. Here's your volume pot. Here's your center tap off the volume pot. You can see all that. And what I did was, originally what they had was the, if you look here, they had the resistor up on the switch. Okay, so where you have the capacitor right here, that was the resistor. And then the capacitor was down here where the resistor is now. So I swapped those two components. Now what does that do? What that does is, when we short out this circuit to take loudness out of the picture, we're shorting out the capacitive component rather than the resistor. The other thing I did was we changed the values here. It originally was a 27K and a 0.2. And what that did is that really made it quiet and kind of hollow sounding. Just didn't do what it was intended. So we dramatically reduced that capacitor to a 0.02. And we dropped the resistor to a 22K and then swapped their position on the switch. And when I did that, it actually sounds pretty good now. The amp sounds a little louder when you turn the loudness switch off, and the reason is the way these components are right now, trying this out, they're actually taking a little bit of the mid-range out as well. So it does do what it's intended. At low volumes, it gives you a more smooth sound and a little more bass. So I'm probably going to leave it. I kind of like the way it sounds, even though you do hear a distinctive change in perceived volume. It's really just kind of playing with the frequencies a little bit. But that's what loudnesses do. Anyways, I'm happy with it. I'm leaving it. What else can I say? So we got this all cleaned up. I got the bias and the balance set. I went and did it again. I ran the amp for a while and then checked my settings, touched them up just the teeniest little bit. If I were to do this over again, I probably would replace the balance and the bias pots with 10 turn. Now those are really expensive, but I think it would have made it easier to adjust. I'll be right back. Okay, I'm back. And as you can see, I have set this up for some final alignments. And then there will be one more thing I got to repair on this, but we'll talk about that at the end here. So what I have connected right now is I have my signal generator, you can see up here, and it's set, as you can see, hopefully you can see, you can't really see, huh? There, how's that? It's set to 1 kilohertz at 10 millivolts RMS. Okay, it's very important. And what we're going to set right now, we saw how to set the AC, balance and the bias and all that. That's all done. We're going to set these two pots right here. And what those are going to do is they're going to adjust the RIAA balance for the phono. So we're putting a 1 kilohertz 10 millivolt signal into the phono inputs, and we're looking at the scope down here at the output of the tape recording outputs. Okay, so we got the recording outputs here. I don't know if you can see that. See if I can get some lights and such. There we go. How's that? So you can see basically you're getting an output, and it should be somewhere around 1.1 to 1.14 volts RMS. And you can see I'm getting 1.09, so around 1.1. So it's pretty close. This is already, I adjusted it already because it's real fiddly to do on camera. So as you can see, with 10 millivolts in, I should get this many millivolts out. Okay? Now, here's the next step. Once you adjust and verify where you are with this, you're starting out with these pots wide open. In other words, at maximum resistance. Okay? So these two pots down here, right here, see where I'm pointing, that one is set to maximum resistance. And we're verifying, again, about a 1.1 volt output, okay, at the tape jacks. Now what we're going to do is we're going to go back up to here, okay, and we're going to change this. First of all, we're going to change the frequency to 35 hertz. Okay, so now we're putting bass into it. This would represent a low frequency on the phono cartridge. And because phonos put out a lower voltage in the lower frequencies than they do in the higher frequencies, or nonlinear, we're going to compensate for that now. So we're going to go with an amplitude of 1, should be 1.23. I'm just setting it to 1.2 because that's all the resolution we can get on this, millivolts RMS. Okay, so we're going from 10 millivolts at 1 kilohertz to 1.2 millivolts at 35 hertz. Okay, I'm trying not to confuse everybody here. Stay with me. Replay the video if you need to. Now we're going to set our scope. And basically what we're going to do is with that 1.23, which is 18 point some dB down from the 1 kilohertz drive signal, we're going to adjust that pot until we get approximately the same amplitude output. Okay, and they're saying you want it to be just about the same. Okay, so actually I have it a little bit higher. They actually want you to have a little bit higher. Okay, so you can see we can adjust that till we get about roughly the same thing. Okay. Right like that. Okay? And that's really all we're trying to do right now. Okay? So basically what that's doing is that's compensating for the nonlinearity of a magnetic phono cartridge. Okay? So that's what RIAA is all about, if you've heard about that. In other words, a phono cartridge doesn't put out the same voltage level at every frequency with the same amount of signal going into it through the, through the stylus. The bass notes are low. So if we didn't have this set up like this, what would happen is your records would sound very tinny. They wouldn't have any kind of bass to them. There would be no balance to the sound. It would be all over the place. So what we're doing is we're compensating for the frequencies that are dropped out by naturally by the cartridge. So that makes sense to you guys. Okay, now I know all you audiophiles and electrical engineers will come out and no, it's this is what it really means, but I'm paraphrasing. That's pretty much what this is. You're making a compensation for the output of the phono cartridge at low frequencies to compensate with what it would put out at higher frequencies. Okay? I hope that is a little bit clearer than mud to you. But that's the final adjustment on this amp. Now, that being said, let's go back into our tape inputs, or our auxiliary inputs, and let's focus in on the speaker output, and let's just see what kind of performance we can get out of this amp. Oh, and I was going to tell you, there's one last issue I have to repair, and that is on the treble control. When I adjust the treble up to the maximum setting, like turn it all the way clockwise, for some reason the treble control is making it almost like some sort of an oscillation or something is taking place, and I don't know what that is because I haven't quite it hasn't dawned on me yet what's causing it. But if we go back to the schematic here for a minute, and if you look, so here's our tone stack, okay? And these are the component values, just in case. Take a good look, okay? I'm not going to do a link on, or anything like that. Just look very carefully. These aren't marked in the manual. I measured them on the old couplets, and I looked them up based on their part number, and this is actual what they are. 100K for this resistor, 100K for this resistor, 120K for this resistor. These are 0.0047 or 4.7 nanofarads. This one's a 330 picofarad. Okay? So just know that that's what those are. When I turn this pot all the way to here, this oscillates a little bit. I get some noise. So we're going to have to troubleshoot that. If I'm running this even just a hair off of maximum, everything's perfect. There's no problem. And the bass works perfectly. No problems with bass. So we're going to have to look into this a little bit. I have to scratch my head a little on it and think about it. But that's a small potatoes there. Not a big deal. So anyhow, let me reconfigure this, and let's look at what the output. You did get a little chance to hear the amp with a little bit of music, and I am going to actually connect this one properly to my Klipsch speakers, my downstairs Klipsch speakers, and try to use a decent microphone and see, who knows how good the sound quality is going to be. But we're going to do an experiment. I think this is going to be a good thing. I just want to see how it's going to sound when we post it up on YouTube. So let's do some performance evaluation through the dummy load and then put it all together, and I can show you I got the cover painted up and everything, and do one final music test on the big speakers. So stand by, we'll be right back. Okay, we're zoomed in. We have our 500 millivolt 1 kilohertz signal going into the amplifier to the auxiliary jack. I have my tone control set flat, and let's take it up and see, and I'm going to just read off to you the actual voltage, the RMS voltage. Okay, and you can see as we go up, right about there's where we're clipping out. Okay, you can just see it starting, and that's about 15.8 volts RMS. Okay, 15.8. All right. So at 15.8 volts, that's giving me about 31 watts, 31.2 watts per channel. So this is about a 30 watt amplifier. They're calling it a 35. I'm calling it a good clean 30 watt, 28 to 30 watt per channel. Now, the next thing we want to do is let's drop our frequency down to 35 hertz, okay? And what, excuse my arm there, my reach. Okay, and let's change the scale a little bit on the, I have to really slow this one down. Okay, and let's bring this back up, and we should be able to get the same kind of output, roughly. And right about there we're starting to break up. That looks about good there, right? And that's about 15.6 volts, so that's just about 29 to 30 watts. So it's staying pretty flat, what that's telling me. Okay? In other words, it's breaking up about at the same power level between the mid-range and the base. Now, let's put a 10 kilohertz signal on there. Excuse my reach again. And we're going to have to change our frequency again here a little bit on the scope. There we go. So far so good. Let's bring it up. And stretch that out a little more. And right about there. And that's about 15.8. Back to 15.8 again. Okay, so back to our 31 watts. So what this is telling me, let's do one last, we'll do 20 kilohertz. Okay, and there's your 20 kilohertz. And you can see right about the same place, about 15.7. So this amp's pretty flat all the way across the board, and it's pretty much doing its job. So I have to say this one turned out good. Again, these were never built to be what I would call a modern audiophile amplifier. There's a lot of places in all these switches and dials and, you know, wafer switches and things, you can get noise and things, but as you can see, it's a pretty quiet amplifier. Now the next thing I'd like to do for you is I want to hook up a set of small speakers just so you can hear, my bench speakers, and I want you to hear how quiet this amp actually is for being an old tube amp with none of the covers on. I don't have any of the covers on the tubes, I don't have any of the screen around the top, or I don't even have the bottom on this. The bottom's hanging open right now, and I have all this crap going on my bench. I want you to hear with volume all the way down where we are. So let me get that hooked up and I'll be right back. Okay, I have just a small set of speakers connected, and I'm going to bring you up out of the stand here for a minute and do wobbly cam for you. But I want to get the microphone right up to the speaker so you can actually hear real world the amount of hiss that's in this amplifier when it's down at zero volume, which is really important because any hum, you know, hiss and hum, these were known to have a lot of hiss and hum to them at low volumes. But let's get right up to it. So here's my speakers. Come right in on you. You can hear right in there. You got your ear a lot closer than I can right now because it's up on my shelf of my bench, but hopefully that gives you an idea of real world. You know, I'm down here in the basement and we have the clothes dryer running. I hear absolutely zero noise out of the amp. Now I'm sure when it's dead silent I can hear a little bit, But for one of these old amps, I have to admit it's pretty good, and that's why in the beginning of this video series I was talking about putting in a choke coil. But really, after I did the capacitors and did the resistors and redid the components and got everything wired up nicely, it's quiet. And I don't think putting a choke coil in there, for the line stage and so forth and the driver stage is really going to make any difference at all. So, I turn it on. Nice tone. So I think we're good, and so I'm going to call this one a wrap. I'm going to button this thing up. I am going to look at that treble, and I will let you know what I find when I get it. And the cover and the bottom cover and top cover for this are down in the shop drying. I've repainted them because they kind of needed it. They had some surface rust they need cleaned up. So once I get this all put together and get that treble problem fixed, I'm going to hook it up to my Klipsch speakers, and maybe we're going to set up my my USB microphone. I actually have a pretty nice one that I've been wanting to try out, and we're going to do a real test on the sound and see what it sounds like. So that's probably not going to be for another day or two, but through the magic of YouTube video, for you it'll just be a split second. So we shall return. Well, there it is, minus some knobs. I repainted the top, as you can see. A little bit dark down here. It's down in the basement here with my little test rig. This amp really turned out nice. It's funny, this thing only puts out about 30 watts per channel roughly, and this guy down here is rated at 60 a channel, and this thing keeps up with it. It's unbelievable. So here's what we're doing. We're doing an experiment with this video. Right now I have my MP3 player connected to it with my little man stuck in there, and I got some music on, and right now you can just kind of hear see I have some stuff in here. And I'll show you. These are some Klipsch speakers. And funny story about these speakers. I purchased these in a big box store at a discount. I got a huge discount on them. But they are supposed to be reference speakers. And if any of you know anything about Klipsch reference speakers, and you can see the copper woofers and the Tactrix tweeters here. Anybody that knows anything about these Klipsch speakers knows that the reference is some of their best, really good speakers. Without getting into the horns, getting into like the Klipsch horns and the Cornwalls and the, the Heresies and all those. But for their modern ones, these are great. This is not exactly a reference speaker, believe it or not. First of all, you can tell when you pick these up, they're not nearly as heavy as an actual reference speaker. The other thing is, you notice the port, there's a single port that's on the front instead of on the back. Now, I have a real set of references upstairs that we can compare to, but what these are is they're kind of a hybrid speaker that was sold at some of the big box stores. They took one of their lower end speakers, mass-produced ones, and they just kind of swapped out the better woofers in them. And I have to admit, for what they are, they sound really good. Now these ones have the 8-inch drivers. The ones I have upstairs are the 6.5-inch drivers. And I can tell you, these will keep up with my really good reference speakers, but they won't do better than. So definitely you get what you pay for, but for the price, I'm pretty happy with them. They're pretty good. Like I said, they do pretty well. classical for you all. But anyways, here's what we're going to do. Sorry about the moving around camera. But basically what we have here is I have one of these blue microphones. I don't know if you've ever worked with them or not, but they're supposed to be a pretty high quality USB microphone. My kids use them a lot for their band demos. You know, for the band they have to record their music, and it's graded and so forth, and it works fantastic. So I thought I would set this up in between my speakers, and we would do a test to see how it records using this amplifier and these clip speakers. So I've done that. We're going to close out the video with this. I'll probably just put up some pictures in the background and let you listen to the song. And I chose a one off of the YouTube library, which should let me play it all the way through, and hopefully we won't get dinged because we downloaded it from the public library, the YouTube library. And let me know how it sounds. I'm really interested in seeing if this works. So this is it. The treble, I never did get it perfect. If I crank it the whole way up, I still get a little bit of high frequency oscillation. I tried everything. I'm going to have to mess with it. I think part of it has to do with maybe I did run some coax, you know, shielded wire, and that really helped a lot. So I still think our problem's related to that more than to circuit design. But it's good as it is. Everything works great. The loudness works. All the controls work. This amp's done. So anyhow, let's end it up with the recording here and see how it does, and you guys let me know. I hope you enjoyed this video series on this EICO Stereo ST70 integrated amplifier. It sure was a lot of fun for me to do. If you have any questions, just leave them down in the comments, and as always, if we did good, give me a thumbs up, and more to come. We have lots and lots of stuff coming. I have a couple of test equipment videos I'm going to do, and then we're going to get on to some solid state equipment. I think we've beat this tube equipment to death here. Done quite a bit of it. So, alright, you all have a wonderful time, wonderful weekend here, and more to come.